Okay, I have no idea if this is actually going to work. Because I pre-scheduled this stream in YouTube, and then I connected Streamlabs. I don't know. Let me know if you can see this. All right, can you guys see me? Confirm if audio is okay and if the video is okay. And also if I actually ended up on the right stream. Cool, great. That's good. I was a bit concerned because in Streamlabs there's like go live and then I'd pre-schedule it for the first time in YouTube. So I thought, okay, I bet you it's going to set up a new stream now. Apparently not, so that's good. Oh, it's scary. I see my own face. I don't like that. Let's get rid of it. Okay. All right, I'm just going to set up the chat so I can see everything properly here. All right, folks, welcome. It's Thursday. There we go. There's the official start. So this is the 4th live stream now. And let's put some weird music on. Some random stuff here. So it's the 4th live stream, and I've been thinking a little bit about what to do still. And I've come to the conclusion that I'm going to do probably some streaming and mixed, like some premieres as well on Thursdays. And then I'm going to spend some more effort and do proper videos. I think that'd be good for my channel as well and for everyone else to get a proper compiled tutorial. It's fun now with Blender 3.0 being released and everything. So I'm looking forward to releasing some new content about that and also some like compacted Unity tutorials. Last week we did some like a premiere where I showed a little bit of what I'd done on Line War. And I understand that that's very difficult to follow, but maybe it's cool to see like an insight on what's going on. But overall, like I'm going to try to keep the tutorials maybe to like 20 minutes, 30 minutes compact, and then maybe I'll do a long one, of course, as well. So I'm going to check out all my chats. So bear with me. I'm just going to set up. For some reason, I've lost my chat history here in OBS. So let's see if I can find that. Don't know why that is gone, but never mind. I can move this one across. All right, so let's check it out. So Unity, though, really, yeah, I know. I'm going to switch. I'm going to try Godot at some point because, funny enough, I'll share you this actually. I sent this tweet out, and because I started a new Unity project yesterday, I was going to test some stuff out. Because I'm working in an older version of Unity. I'm working in Unity 2018, believe it or not. That's actually end of support. So that's what we're going to migrate Line War from that at some point when they finally, after like 4 years to 3 years, decide to come out of like the deprecated netcode stuff. So we're going to upgrade that. But I've started the Unity 2021, and I thought I'm going to make a tessellation shader because that's what I've been using in the game. And then it turns out that the URP pipeline doesn't support tessellation shaders in Shader Labs or in Shader Graph, which I thought was ridiculous. I know that was the case like a few years ago, but I thought surely that can't be the case. But surely it can be because it doesn't support tessellation shaders. So, okay, I thought I'll check out the HDRP, so the high definition render pipeline. So I started that one up. And first of all, for anyone who's starting development, if you pick the HDRP pipeline when you start Unity, you're probably going to scare yourself out of the product faster than any human possibly have in the past, because it's really done for a lot of customization and like squeezing optimum performance out, but at the cost of like developers, especially new ones, having absolutely no clue what to do in there. And even though I've been using Unity for like 10 years, I really don't like the workflow of that one. So someone proved me wrong. But then I thought as well, I'm going to show you here because check this out on my screen. I sent a tweet out with this screenshot, and believe it or not, I started a blank HDRP project in Unity 2021.2, and after it took about 3 minutes to just start, and you can't like deselect any assets or anything, it'll just start you on a clean project. 32,357 files in 1,624 folders and 1 gigabyte in size. And that's just to get started with a new Unity project. So I went on a bit of a rant with this tweet here, actually. And it actually gained a bit of attraction as well on when I was looking at the comments. because it's absolutely ridiculous. I think they've since they went to become a public trading company, they have to probably boost their like appeal to attract investors and stuff. So they're like spreading across, trying to like squeeze more performance out of the product and add more services. But I strongly think it's at the cost of the flexibility that made the Unity like successful to begin with. So I think they switched into this package manager, and it's all this bloat stuff that comes with it. So all those 32,000 files, that's just to have a blank project. And then you have to delete the example assets. And even if you delete the example assets, you're still at 31,000 files. So it's not that much of a difference. So unfortunately, slipping away there. And that's why I'm going to try Godot, because people are saying there that it's so much more lightweight, and I can totally understand that it is. So I'm looking forward to testing that, and I'm actually going to record that. I know I've been saying that to Arvid for a long time that I was going to do it. All right, let's check this out. Didn't I transition? No, there I did. Let's have a look. Why can't I get my chat? Like, it doesn't look the way I'm used to. There we go. Let's check out the... Yeah, Jules, Unity's getting pretty bloated again. It's totally true. And C#, I like... oh, right, okay. Do they have their own language or something? Don't they use C#? That's going to be a problem for me. So for a blank project, yeah, whoa, that's whoa. So I've been a while since I tried Unity, but I'm loving UE4. I'm actually going to try, but I believe Unreal Engine is... I had a lot of comments saying that one's pretty much very bloated as well. So I don't know what your experience have been. Let's see. Jim, my friend there as well, my 60 meg hard drive, yeah, those were the days. Everything was in DOS. That was cool. All right. So if you saw the teaser, this week we're going to do some stuff that I've been working on the game as well. I use render textures a lot, and basically instead of having a camera rendering to your screen, you can have the camera rendering to a render texture, and you can use that texture then in your shaders and for materials. And I've used it in Line War for stuff like deforestation, when you when you construct a building, you want to erase some trees. So I've used like a render texture that renders just like little footprints of white blobs, and that'll suppress the trees with a shader. Same thing goes for some of the like water rippling effects, or when I offset some of the mountains and stuff. When you build things, you want to flatten some terrain. I've used that quite a bit. And it's a really handy way to do it, and it's quite performant as well, and combined with a tessellation shader. And the tessellation shader just takes a few vertices and just makes loads of them, and like creates like a web, but everything is done by the graphics card, so it's really fast. So I thought I was going to do a little setup of that one and play around with it. So, and what else have I been doing? Done a little bit of this as well. I tried one of my characters. I've had some questions if they run in Mixamo. So set this one up for a test. Let's see if I can get my hang on this one. So I've imported this little guy. Seems to be running pretty good in Mixamo. I thought the thriller animation was pretty good. So I could also set the tutorial to bring like the low poly characters that we've been modeling a lot last year and the year before. It's quite easy to get them both into Unity now with the correct rotation, and there's a few things to get them into Mixamo, like the shader in the Blender, for example. You have to get rid of fancy stuff like normal maps and stuff. Just have our palette texture plugged into the base color. That's all you need, and you can't really have anything else. And then you zip up your FBX file combined with the texture file that you have in your material, and then you submit it to Mixamo, and then they rig pretty much straight off. You can't have the same FBX export settings that you do when you do it in for Unity. You have to change the different like Z-axis and stuff, but it's pretty much default settings when you export it to be used for Mixamo. All right. Let's get back to it. Just a few more comments then before I start the new Unity project here. All right. Yeah, they look I liked just playing around with the Mixamo animations. I was surprised that the feet planting and everything worked pretty good. I usually model like bigger heads on the low poly characters, so some of the animations, especially that revolve like where you do flips and stuff, could need some work. But all right, let's go back to the mainstream window here, and we're gonna get started now. Here we go. So when I start Unity 2021, apparently .1 now, didn't I use .2? Let's do .2 instead. There we go. You get to pick whether you should do like the traditional standard pipeline or 2D or the URP pipeline, or if you want to go high definition render pipeline down here, and all sorts of things. And for new projects, okay, here's going to be a tricky one to recommend, because URP, Universal Render Pipeline, is designed for ease of use, lightweight games, customizability, like creating up-to-date modern graphics for games. That's going to be easy to use. So that's what the Universal Render Pipeline does. HDRP, High Definition Render Pipeline, that sets up a new like customizable render pipeline, but it works very, very different in terms of exposure for the camera. It's very easy to overexpose things. All the settings are quite tricky to get a hang of when it comes to lighting, lighting probes and everything like that. So I'd say that if you're going to make a game like a first-person shooter or an adventure game, and you have a team of more people that are skilled, and you really want to squeeze performance out, go for HDRP. Otherwise, I'd normally recommend URP, which is Universal Render Pipeline. I was pointing at the 2D one here. So, and the reason why these are the two new render pipelines that Unity have like released from a couple of years ago, and this one was also used to be called lightweight render pipeline, I think, but they've changed it to UDRP. And one of the main reasons for using this one would be to use the built-in shader node editor, which is called Shader Graph. And I used to program my own shaders using the shader language, and that's super difficult, I'd say, because you have to program them. First of all, it's a different language, and then you have to code them. So because the GPU will process everything in parallel, so it's not like a normal program where you go like hello world and then like a for loop of that. You have to think that everything that comes in is distributed like across all the pixels at once, so it's quite difficult to get your head wrapped around it. So that's one of the reasons that finally, when that came to Unity with the URP and the HDRP, I thought that's going to be great. I can finally like use their built-in shader editor now, but it sucks. So that's the bad side. I've given it so many tries, and I actually realized why I haven't started to create a lot of tutorials on it, because every time, like during the past year, when I've come into Unity and I thought, I'm going to create a tutorial now, so let's bring up shader, I even say shader labs all the time, but shader graph, and then I run into problems because, okay, so this one's not supported, that feature, and I Google it, and I think, surely it must be supported, and nope, it's not implemented, or it requires HDRP, or it's in preview, or it comes with additional customization. So that really, really is terrible. So my recommendation, if you want to like start using Unity, and if you want to like get right into game development, if you want to be able to use shaders and use a shader graph, I wouldn't even actually use shader graph anymore. I'd go with the 3D pipeline, which is the built-in one, because that's still the one that actually has more features than the URP. Because when you do a feature comparison left and right, the standard definition or the standard pipeline actually still has more support and customization when it comes to, like, I want to trigger my own render of a texture, render texture, for example. It doesn't work in a URP. So for this project, I'm actually going to boot it up in render texture 3D in the good old one. Still takes forever to launch them. While that's starting, I'm just going to check the chat here. A really basic shader tutorial would be great. I'm actually going to do a very basic shader in this one. And everything's going great. Thanks. Welcome for coming in. Let's see. Got a few people joining here. What's going on? Yes, a Unity project. We're booting up. I'm going to do... don't know if anyone saw the trailer, but I'm going to do a few testings today. So I'm going to close this one. Matt says it's a shame Blender and Unity can't share the same shader tech. Yeah, that would have been nice with the geometry nodes and everything. I sort of understand maybe that they don't, since it's like a... Maybe for Eevee it would have been closer since it's like a graphics engine, but it would have been nice with some more compatibility. I usually use very basic shader for my Blender stuff. So that's only like a maybe an emission texture and a base color texture or albedo texture and a normal map. And then all my other shader works is usually custom stuff. I have to always achieve different things like in the game. And a lot of it is shader, and either you affect like the colorization with a fragment shader or a surface shader, and you use vertex shader. So I'm going to show a little bit of that. So today it's no Blender modeling. Today it's Unity for a change. I've been doing so many Blender videos that I'm going to install Blender 3.0 very soon. I haven't even installed that one yet. And how I get my... It's still loading the project, by the way. I'm not forgetting it. It's still loading up my Unity project. Insane. Why is it so slow? Check this out. Loading initial domain with user assemblies. I'm using a program called Fences for my desktop, if anyone's wondering why it looks like that. And that's how I can group the icons together in Windows. Pretty useful, but I think you have to pay like $20 or something. All right. Okay, so let's get started. I've just started a new one, and unfortunately I've got to do one thing which I really wouldn't actually like to do. I really wanted to use the the built-in shader or shader editor, shader graph, because it comes included in Unity. And I rarely actually, even though I'm an asset publisher myself, I try to go everything native in Unity as possible if it's like editor stuff. For content-wise, you know, the assets are good, but often, if there's a built-in feature, I'd like to use it for the editor-wise, whether it's like text or sprite packing or anything like that. But saying that, I'm actually not going to use shader graph. And a while back, maybe 3 or 4 years ago, I bought an asset called Amplify, and that's actually moved now into the package editor. So they went away from the asset store a lot, and they went into the package editor. And in the package editor, you can actually access assets that you have, my assets. And am I even showing this? Yeah. So I have this Amplify shader editor here. So I'm going to import this one. And it's actually on discount now. I'm not promoting this. I'm not paid to say anything like that. I think it's half price, maybe $30 or something. But any day of the week, any day of the year, even any day outside the year, I'd recommend this one because I think it's actually super, super good to compare. If you compare them side by side with shader graph, it's just so much easier to use. All the features are there. It just works. So apologies if I'm actually starting this video with an asset. But saying this, you could, if you want to, you can try to replicate this workflow in shader graph. And if you tell me afterwards as well, if it was easy or not, you're a better person than me because I just do not like the shader graph in the same way I like this one. But saying this, you could actually even write the shader itself. Like I said, I used to write them, but so with the shader graph now, everything's so much faster to create things like that. So. All right, so I've just got a blank scene here now, and this is what I like about the original 3D project as well. You don't come into all the bloat that the URP and the HDRP projects have. They usually have loads of example assets. They've got light probes set up. They've got like reflection probes, and I don't know, you name it, they've got it. So I like coming into this empty look. And the first thing I'm going to do, I'm going to create just a 3D object, and I'm going to create a plane here in the center. And let's make it like 5 by 5 maybe. Or even if, maybe we'll stick it, yeah, 5 by 5 in size. Here we go. So I actually did something similar to this just beforehand. So to test it out, that it worked. That's why I got the stuff for the trailer. So let's call this one snow. That's just going to be our snow surface here. Simple plane doing nothing else at the moment. And then I'm going to create a camera. So I'm going to right click here and do create empty. And I'm going to call this camera. And then let's add the camera component. I could have actually added the cameras. And I added a secondary camera here. And I'm going to rotate this one so it points downwards. And I'm going to switch from perspective to orthographic. It's very important to get the camera facing down and it's not rendering with any perspective then. because I'm going to create a particle system now, like I showed in the trailer, where it's actually recording that with this camera and then translating that into texture so we can deform this mesh here instead. And I have to change the size of this camera. If I do it to 10, I have to get the size. Okay, let's make this one smaller again then. Let's see, 2, 2, maybe 2 and 2. Should really clip this one. So the camera size needs to match the render texture there, or the plane mesh. We can come back to that probably and tweak it a little bit. And then I'm going to create a particle system here. So I'll right click, create another empty, call it particle system, and we'll add a particle system here. And that just sends some particles across. So I'm not using the visual shader graph. This is the default good old particle system here. And for the shape, I'm going to change it from a cone here. And let's set it to like a circle. Then we can, either we could rotate this whole object, or I can change the rotation here to 90 degrees. And then we'll change the size to like 0.1, so it emits it right from the center there. And then I'm going to change the shapes here as well. I'm going to go with the render. We can just switch this material to like a default particle. I'm actually using a bigger screen so they disappear a little bit. So default particle, and there's our just like a little particle flowing here. And let's create here in the assets as well, right click, create a folder called demo. I'll try to keep everything in this demo folder here. Keep it nice and tidy. So let's see, what should we start first? I'll create a render texture we'll need. That's the whole key thing behind this one. So I'll right click, and then if I can find it somewhere, render texture. So here I can set the dimension. We'll keep it at 256 by 256. I think I'll keep everything here by the default for now. And this is like normally you'd import a texture into Unity, and by dragging any like image file into Unity, you would be able to use as a texture in a material. The benefit with the render texture here, we'll just name it render texture, is that you can have, like I said, either the camera or different stuff working onto this texture and changing it on the fly, which is going to be really performant. So for this camera now, I can change some things. First, I need to change the culling mask here. Unity works with a lot of layers. So if I have like by default, everything is created using this default layer. But if I click on this layer up to the right, when I've got the particle system added, I can add a new layer, and I'll put this one at the bottom here. So I'll just call this one snow or something. And I'll come back here, and that was just to create it. Now I have to pick it. And nothing will happen to begin with, because all I've done now is say that my particles are supposed to be rendered on the snow layer now. And the layers are good for two things. One is that you can actually pick which layers a camera renders. So if you want to hide the objects, you can stick them onto a layer and then just not render them with that camera. Another thing layers are good for is for collisions. So if you have like two objects that should or shouldn't collide with each other, you can stick them on different layers, and it's a super fast way for Unity to separate the physics and not collide things, because you'll gain a lot of performance by splitting those into separate layers. So maybe all the small debris, you don't want that colliding with the world, then you stick that on a separate layer. But we're going to use it for the culling mask, and if I look at the main camera here, I can go, you can see that a culling mask here is set to everything. So I'm going to take away snow now. And it still shows in the editor now, but in the game view, it should disappear. Or it will disappear in a second at least. It's still showing because it's actually showing this camera. So this one is set culling masks to not show the snow. And this camera, I'm going to change so it only shows the snow. So I'll set it to nothing first and then pick snow. So the only thing this camera now is going to render the particles that this particle system is generating on this layer here. Let's see. I hope I actually ended up thinking that it was. I think it is. Yeah. Trying to remember if it's actually allocating the layer here, but I think it is just on the parent there. Okay, so now one more thing I need to change here as well. So for this camera, I need to select a target render texture. So let's see, we should find it here somewhere. Target render texture, and if I click on this little thing, I can pick the one that I created. I could have dragged it as well. And the only thing this camera will render now is that render texture, or it'll render those particles to the render texture. So if I press play now, I'll have my main camera view. This is where I'm showing, and nothing's really happening yet. So we're going to take the next step here. Now we need to start to create some materials as well. So I'm going to right click and create a new Amplify shader, and it's going to be a surface shader, and let's call this one Snow. And bring that in here. So this is the shader editor that is the third-party asset compared to the shader graph. What I really like about it is that everything about the shader is accessible to the left here. It's really abstracted and hidden away, I'd say, in shader graph. Here you have got access to everything that you need. And it's a bit similar to the way it looks in Blender, I'd say. So you have, like, this would be the base color, you have the emission, and it's, again, that's a little bit similar to the way it is in the shader edit. I keep saying it wrong. In the shader graph. But this one has got all the features, and stuff like tessellation and things like that doesn't even exist in that one. So that's what I like about this one. So we're going to add a texture, and to add things here, I'm going to press space, and then I'm just going to add image effect. Oh, no, I'm not. Actually, I'm going to add a texture. Let's see, texture sample. And I want to change this one. It's already a property, so we're going to call this one render texture. And I'm going to drag this one so it just shows on the albedo here. And can switch on automatic saving for now. And we'll have to create a material now. I'll just move that out of view. Right click, create material. I'll call this one Snow. And then I'll change this shader here, or I have to rename the shader. It's already renamed, so Snow there. And when I select this one now, this one is not mapped by default, so now I can drag my render texture into that slot. And then if we press play, we'll see if we start to get some. Now we can actually see that it's got at least some things here on this one. If I click on the render texture, I can see that it's rendered a few things. And we don't really want the gray background here, so I have to change this one. So on the camera, I can disable the skybox. We'll switch this one to a solid color, and then just set that one to black. And if I press play again, now we need to assign this material to this one, this mesh or the plane that we had before. So you can just drag this one onto the plane there. Press play. And there we go, we can look here. So now actually in the editor, I see both the actual real particle system and I see the texture that is being updated. In the game view, you don't see the particle system because the main camera isn't rendering the particles. It's only rendering this texture now. And what we should probably do is get the camera up so we can see this a little bit from an angle. So I'll bring the camera up. Hard to rotate. E to rotate. So weird in Unity. I have to change my stuff, my clothing line, or my merch. There we go. Maybe I'll do this. Actually, I'll split this so we can see them at the same time. Just drag this window to there. And let's swap them. I want to have the game window on the left. And this one on the right. Press play. And there we go. So in the editor, we see both the actual particle system and we see this surface itself. And in the game view now, we only see this one. So step one is pretty good. Now we need to change. We want to actually start to distort this one. And to do that, I can go into this shader editor again. The only thing we're using now is this render texture is sending everything out to the albedo channel. So it's just rendering what it can see right now. But what we could do is we can offset the local vertex here and send it down. So like based on the color, it'll send it downwards. So let's have a look. And instead of rendering the color, I think I'm gonna set this one to a white color. So I'll press space, add color, change this one to white, like a snow texture. And we're just gonna have the snow. And I'm gonna use the render texture now. Instead of showing the particles, I'm gonna distort them. And we can pick any channel because it's a black and white texture. So any of these R, G, and B channels are gonna be the same color now. And the easiest way to do it is that we could just plug this into the vertex offset. So I press space and I need to append. There's a feature called here. And then I can pick any channel, doesn't matter. I'll pick the red one and I'll put it into Y. And then we can also change this one from a vector 4 to a vector 3. So now vector X will be 0, vector Z will be 0. So in the width and the depth plane, it'll be the same. But we're sending the render texture into the Y offset there. And if I drag this one now into the vertex offset, we'll say this one and try it out. It'll probably look a bit broken now because we haven't enabled tessellation yet. Now when we look here, that we can see that something funky is happening, and that's because if we switch this one to why can I not see? Oh, they've actually changed the naming in this version of Unity. I wanted to show with let's see, shaded wireframe I wanted to see. Okay, where have they put that then? There we go. Okay, so it's apparently this one now instead, shaded wireframe. Apparently I didn't use this version when I did the testing. So we can see that this doesn't have that much geometry to begin with, and this is where the tessellation comes in really handy, because it's just popping up and down now, those vertices. So in this shader editor now, I can scroll down on the left and just enable tessellation. And that instantly added some geometry to it. And we can see it's still not looking that great, but it's added a few like geometry. We can increase this one by going to edge length. Let's just do fixed and then change this one. Change it even more. We can add quite a lot of detail here. And since the graphic, I mean, if you were to do this like a procedural mesh and then have Unity affect all these vertices, it would not be good at all. It'd be super, super slow. But with tessellation enabled in the graphics card, it just does this at a very low cost. I've actually ran our whole game world, our whole map in the world with multiple layers using tessellation. So it's actually quite performant, and you can add a lot of geometry, and suddenly those little weird spikes, they still look weird because they're small and stuff, but we can start to change these a little bit. Maybe we can change the particle size a bit. So start size, change them to bigger particles. And they're going in the wrong direction now because we wanted them to go down really. And we have another problem here, and it's not adding any shading here. So we have to come to that in a second, because even though the meshes actually move in the vertices, but it's not really knowing how to shade this, unfortunately, yet. That's not built in, so we have to compensate for that a little bit, which we'll come to. So in the game view, it looks very strange. We could maybe change this one to this color here. I'm going to change this one to a property instead. Main color. So now we can control the color here, make it a little bit darker. Now you can sort of see that there's a slight shading, but that's just the real-time shadow that's kicking in. And normally if you were to do this like in Blender and import something that looked a little bit like this, then the light would come here and the normals would be calculated. Remember when I tried to explain what a normal was, but it's like this thing that's perpendicular to the surface. So normally, like if you bump up a surface like this, the normal would be pointing to the side. But the problem is that we're just raising the vertex height, so the normal is still pointing up. So in terms of lighting, it thinks that everything is still flat. So that's that sucks a bit. You can get away with it with some cheating, and then we can do it a little bit better in the second run. So, but first, the first thing I want to do is make these go down instead. So I can just press space in the shader editor here and do neg, negate. And then I'll drag this one to there, and now we're actually inversing it. So instead of going from 0 to 1, it goes from 0 to -1. So now we'll have that those are going down here instead as dips with those ones. So far so good. So the cheating way to do it would be to actually just make it a little bit darker in the dips. So if you were to make like a snow surface, maybe you'd get away with it the cheapest way possible, and that's just to offset the color and make it a little bit darker when it goes down. So it wouldn't be the proper lighting, but let's start with that one at least. So I'm going to press, you can select one of these as well. Try to fit this on the same screen. It's terrible. I'm using a suit like an ultra wide screen, and I have to work in the little window that captures by the stream here. I'm going to copy this one, Control V to paste it, change this one to black. So now I want to go from a light color here. Let's go nearly to white again. I want to go from this one to this one based on how far down I've offsetted them. And I often use a thing called a lerp, and that's a linear interpolation. And it goes from one value. So I want to go from white to black color. And then whatever I plug into the alpha here will determine how much it should fade. So if I just straight plug in this one, which is going to be the same channel that we used to offset this one, and then plug this one into the albedo, it'll lerp from the white color to the black color, and then it'll do it based on this value. So now when we look, we can see that the dips here are going darker. And again, it wouldn't really look that realistic, but if you have like a nice snow texture and all you want to do is make some footprints, this would probably be the cheapest way to do it, that it just offsets these ones a little bit. We could also, let's see, that one's absolute, yeah, everything's good. So let's check, I'm just going to check the comments meanwhile. The way it tessellates looks weird, doesn't it? Yeah, I think it works in some weird algorithm that just connects them all together. All right. Let's see. All right, cool. It looks like you're having a good time to chat to yourself there. That's good. I'm noticing very different from the Blender one. On this one, I have to focus a lot more on what I'm actually doing. In Blender, it's easy to just like go with the flow and model some stuff. Here, you have to think, okay, am I doing the right thing now? Am I connecting the right thing? Does this make sense? So hopefully you can get something out of it, or if you're watching this retroactively as well. Okay. What should we do next? Maybe we should do the proper way to do it. Maybe you want to affect how much this effect is taking place, how much we're offsetting. I can introduce a new variable. I press space and do, well, I want to have a float variable here. Float. And then call it mesh strength maybe. And then with this one, I have to switch from type here. I want to do it to property so we can access it in the material editor. And then I'm going to multiply this value. So I'll plug the mesh strength here and the red channel into B, and then I do the negate here. And we can change this one, so maybe you can go from 0 to 10 or something. Default value is 1. And that introduces the slider, so now I can drag the slider and just affect how much it's deforming these. And again, this is taking the particles, rendering them with the camera, and then putting that onto this render texture that we've created. And then the material here is using that render texture to just change this offset down and slightly like colorize this. Like if you wanted to do lava shaders and stuff, you could do the same. Let's expose this color as well. We've got main color there. This one's going to be called dark color maybe. And you could also change this one to the emission, just testing some different things. And then you could go from like orange to like red or something. So you could theoretically create different lava flows and stuff like that that's animated. And again, everything is accessible through the particle system. So anything you make, still in edit mode, or am I playing? I'm actually playing this. stop it. This should really work in the editor, I think, without playing as well. So I made some changes there. So when I've got the particle, I can press play here. It should really work in the editor too, yeah. And I changed some sizes here, so let's change this again. Start size maybe 2. And let's randomize the speed a little bit. Between 3 and 5. And lifetime maybe 20 seconds. 1 to 2. And we can increase the counter as well. Let's go for a maximum of 10,000 particles. And change the emission rate here to like 100 per second. And they're coming in, we can fade them as well maybe. So in the particle system, I'll do color over lifetime. And this is the Unity particle system, so we'll go from black to white and back to black. So now it fades the particles in, and then it fades them. It's a bit messy in here now. Maybe I should switch this to shaded just again. We can see now it's, I don't need to press play. Okay, let's just highlight the particle system and press play. So you can see now it's rendering a lot of particles, and it's taking those and using those colors now to just distort this one. You could, I guess you could just duplicate this particle system and offset it a little bit. And you could have 2 doing the same thing. You can combine them. And I don't know what the frame rate is now. They've apparently changed that overlay as well. It used to be a drop down here. Let's see, game view, stats. And okay, it's disabled it. So new stuff in Unity, let's check that out. But it's running super fast anyway, so that's good. Okay, I think one of the difficult things now is to get that thing correct with the shading, and that really has to work if you want to use it properly. So let's go back to the snow shader. That doesn't look like snow anymore. Change it to white, and then maybe black here. So let's go, I should actually change. Maybe we'll introduce a slider here as well for that one. So that's the mesh strength. We can copy this one, Control C, Control V for this float property. Call this one color, right, color strength. Copy this one. Grab this value, multiply the color strength by the red value from the render texture, plug that into here. And now we'll, when this one's compiled, we can change the amount here as well on the color strength. And this one only need to go, it doesn't need to go from 0 to 10, it can go from 0 to 1. And there we go. So now you can control the strength of that effect, that it goes darker the further down it goes. Okay. So now we need to do the tricky thing, and that's to get, without the colorization effect now, this should really be looking correct as well. And I had to spend some time thinking about how to do this, because you can't really calculate the normals on the fly. And I saw on when I Googled it, which I do a lot, by the way. I don't really know all of these things in my head. I'd like to, but I have to Google a lot of stuff all the time. When I do the game development, half my time is just Googling snippets and like seeing how other smart people have solved things. Math is not my strong thing, but I remember solving like this issue for the game, for Line War, for our offsetting the world. I had to recalculate all the normals after I distorted them, because all of those meshes are procedural. Not in the graphics card, but they're procedurally generated. So I needed to calculate all the surfaces. And there is a way to do it. And that's by looking at this render texture. I'm going to try to zoom in on this if I can. And then I'm going to explain this in a terrible way now. In a very, very bad way. Because the shader that we're doing now, it's looking at any given point of this render texture, and it gets a gray value there. And all it gets is that gray value to say it's either black, white, or somewhere in between. And then it's very easy to get that value and then just offset the vertex position on the Y position downwards. So that's the easy part. And then we need to get this local vertex normal recalculated. And you cannot do that from one value. If you just look at that one particular point on a surface, if you had nothing else except that point, it's impossible to calculate in which way the normal is. You have to have like at least 3, but I usually use 4 points on the plane to calculate in the area to see like what is the tilt of it. So if I have like my phone here, for example, if there was just an atom here, it wouldn't know exactly which is up and down. But if I have 4 points and I can like calculate where they are, then I can calculate what direction it is here. And it's an approximation, but the way I used it, I think it's pretty, like it works pretty good. But there's probably better ways to do it. I saw that there was a shaded code from someone named Ronja, and she'd shown it with the normal mapping enabled. It took like a mesh and warped it according to a sinus wave. But the way she did it, he or she, I guess it's a she, you actually could predict from the equation what the angle would be, which we can't. So I had to come up with like my own little custom way to do it. And the nice thing, we haven't written any code yet. So we've got this nice like texture thing, but we don't have any code yet. So I'm going to convert this render textures because I need to sample it in 4 different points now, and then calculate what the angle is for this local vertex normal. So I'm going to copy this render texture and paste it here. And instead of having a duplicate of it, I'm going to change this one to from object to a reference, because then I can reference the same render texture. So there we go. There's no performance different now. It's just the underlying code it'll allow me to drag some nodes into this one now, whereas in code it's the same actual object here. And for this one, I need to look at the UV coordinates of this texture, and I need to look at it a little bit to the left, a little bit to the right, a little bit up, and a little down on the texture, because then I can calculate what the value is on what the slopes are in the 2 directions, and then I can calculate which way the normal is facing from that one. So I need to offset the UV coordinates a little bit. I'll press space and do texture coordinates here. And then I'll drag this one into here. And if I type in a value here now, I can just do offset here on the x-axis. If I do 0.1, it'll be a little bit more apparent. It shifts the whole texture now to the left. So, but I can't really do it that big of a step, so I'm going to do 0.01. So now I've got, with the offset now, the same shader code, like the GPU goes in and gets, oh, I want the height for this pixel. And now I want to look at the angle. And this one, since I'm offsetting the texture a little bit to the side, I'm actually getting the value that's right next to it. So I can do that one, and then we'll just do, I have to combine this into a vector 3 again. And this is going to become the Y value. So again, it doesn't matter if I take the red, green, or blue. I'll plug this into Y. And that's one of my pixels now. So I need to do the same thing now for the offsets that I've done. So, and maybe I'll actually do, so we can multiply this with normal strength here. So I'll do another float space, I pressed, and another float variable called normal strength. We'll expose it as a property, and then set from 0 to 1, where the default value is 0.5. And then before this one, I want to press space and do multiply. And then I'll grab this color here, and then grab it with a multiplication, and then send that one in. And now I can just drag that slider. We won't see any visual effect if I do anything now, because this is not going anywhere. So I need to finish this little thought process and connect the spaghetti machine here to get this to work. So now I'm going to copy these. So I'm going to copy, and let's see, I'm going to need 4 of these. Control V, Control V. And if I offsetted this one a little bit, I'm going to do the opposite. I'm going to do negative x.001 or 0.01. And then here I'm going to go 0.01 on the y-axis instead, and negative 0.01. So now I've got the same thing now. It's going in for this pixel location. It's getting a little bit to the left, a little bit to the right, a little bit up, and a little bit down. And now I'm going to combine these into, or I'm going to, okay, let's see, subtract. So from the left and right, or east and west angle, I'm going to take this one and subtract this one. And then I'll do the same here. For the up and down, I'm going to grab those to there. And then if anyone's really good at math here, lucky for you, good for you. This might be super easy for you. It's not super easy for me. I only know that like with vector calculations, so a vector 3 in this case, we're not using the fourth component. So theoretically, we could change these to, not just theoretically, we could do it practically too. These are all vector 3s really. So it's an X, Y, and a Z component. And if you paid more attention in school than I did, then you know a little bit more about cross and dot products of vectors, because you can actually look at, there's like this rule with like different angles of a vector, and you can calculate like what from two vectors, you can calculate the normal of that one. My approach is very different. I just go, okay, maybe this is the dot product, or is it the cross product? I don't know. But for this case, I figured out that it's the cross product. So I drag the left and right here. So the X offsetted one to the Y offsetted one. And then I'm just going to try to plug this into the vertex offset. And we'll see what happens first of all. And it goes pitch black. So I've missed something. It's a little caveat here. I hate that word. I don't know why it's called caveat. Sounds like caviar. But I'm going to go, and it's because it's going into like, when these values are 0, the X and Z axis here on all of these, I think it's getting into like a gimbal lock type of situation where it doesn't, like it's like division by 0 practically. So I have to do a little slight, just a little nudge so it knows in which plane it's operating. And this is going to be in the X so I'm going to do just the same here. I'll type in, just so it's not 0. And then we'll do the same here. But instead of, we're grabbing the X and Y here from the texture coordinate, and now we're converting it into 3D space. So here I need to go negative or 0.01 and then negative 0.01, because now we're using the Z axis because we've flipped our plane down. Y is up and down in Unity, if anyone remembers, and X and Z is the depth, or the width and the depth. Hopefully that would have fixed a little bit of the problem. And we haven't fixed it yet, so let's figure out. Maybe it's the normal strength. Is that too low? Nope. Okay, I'm going to change the color as well of this one so it's not full white. Okay, I've done some error in here. I'd expect this one to look the same as this one. Reference. Okay. These need to be references to reference, reference. Okay, I'll normalize these two. Normalize is bringing it to normal. Maybe it's too flat, the angle. Oh. So normalize takes any vector and gets it so the vector length is 1. So normalize. Okay, still some issue here. It's sort of working, but it's not. I'll have to increase the ability to multiply that one a bit stronger, maybe. So we're getting some shading here. Maybe we can throw like a ball in here. 3D object sphere. Try to see if that light angle is correct. Okay, we have a light effect, but it's not, it's very have I got fog enabled? Don't think so. See, general, nope, rendering, lighting. No, sometimes I get tricked by the fog effect. Maybe I got these mixed up. So this is my usual troubleshooting process. Did I get them mixed up? Okay, I'm missing something. Strange. Oh, right. Okay, I'm multiplying these by 0. Maybe you've actually commented that in the chat. They all need to be multiplied by the... I bet you in the chat. I should really... It's difficult to keep track of the chat and this stuff at the same time. Still doesn't look right though. Sort of on the right path, but I don't know why it's not shading it as strongly as it did before, but try it. Combine it with the color strength as well. I mean, the shading is there, I just expected it to be a little bit stronger. Aha, okay. it's still plugged into emission, so it's lighting itself up. It's lighting itself up on fire. No wonder. There we go. So I was, it bit me. It was sending the, it was still in emission, so it was lighting itself up. Okay, stuff like that happens. Let's go back into whiter. Okay, let's press play. There we go. So we can control the normal strength now here. And here we have an issue too, I think. Yeah. But let's see. Yeah, it's looking right. I put this sphere here to verify that the light is actually hitting in the right angle, because I usually get that cross vector mixed up. So the light is coming from here, and I can compare it now with the built-in, like the accurate stuff, and see that the shaded area is actually coming on the right thing. So that's good. Flash strength. And here you can get a slight effect now, even without, like if I reduce these both to 0, and let's see. Oh yeah, color strength as well. So here's the flat thing, nothing's going on. Then I can control either the mesh strength, which is just doing like the up and down, and this is the real-time shadow now that's added. Or I can just do the normal strength. So this is not distorting the texture, it's just doing the light is reacting as if it was bumpy now. So that's one way to do it, control it. And then we have the color strength to colorize the dips now. And these parameters now together, we have quite a lot to do, like so we can control this. And some of the usage areas that I'd say is, like I do it a lot for the imprinting, like in terrain. If I want a tire, like tire tracks, for example, or something. If I disable this one, let's just press Control D on this one. And instead of having emission here, rate over time, I'm going to go to rate over distance. And if I press this 2 for every, or if I do 1, for every 1 unit that I move now, it'll spawn 1 particle. But we've got movement on them, so that makes no sense. I'll change the start speed here to constant 0. So now when I move, and we've got some more stuff here. This is, see, it's not actually doing it in the right location. And that's because the texture is rendered, I think it's like just 180 degrees flipped from how it's reading and putting the render texture. So we could rotate the camera 180 degrees. That will hopefully get it to the right location. Because you want really the tire track or the footprint to be in the same place as they are actually happening. And so this one's spawning. Oh yeah, it's moving with now because I need to change the space here from local simulation space to world. So now every 1 unit that I go, it'll like imprint 1 particle. And if I do it over here, we can see that it's over here. And the reason why they're sinking down slowly like this, it's because I had this color over lifetime. So for this particle system, I can just do, let's get rid of that one and go from, straight from white. And now when I do it, it'll just snap it down as if I put my foot down, but maybe you'd want maybe actually a little, let's see, a slight indentation over time there. So it just presses a little bit. And this could be like if you're walking through snow. And usually you'd probably want it to raise a little bit at the end here. And I won't cover that in this video. But I'm just using the default particle now, which is shaded. And I'm using that in like an alpha, like the way it's just writing that into the world. But you could design your own little texture instead that has like raised things at the edges. So like it goes white at the edges and then like slopes on the side. And then you could have that move. And then you'd get a slight like raise up and then a slight in like a deeper indentation. So that would really look pretty good, I think, as if it was proper like footprints that are actually pushing some snow up around it, because you wouldn't just get indentation, you'd probably get some stuff that. And if I duplicate this one, you could have 2 next to each other here. So if I was moving through the snow, you wouldn't jump like this, but you get the point. And what else? Oh yeah, so the indentation will only live now as far as the particle lives. So if we do a particle life here of 1 second, just it'll fade away really fast. Sometimes you probably want like snow to regenerate. And since it's quite performant, and as long as you don't spam too many footsteps, you could have like 100 seconds or something. So then they'd last for a lot longer, but then you'd have to adjust the time that it takes for them to like indent as well. And what else? Oh yeah, but there is another way to do it as well. And there's something called a clear flag here on, I haven't actually checked this before I recorded, but if I go to clear flags somewhere here, rendering path, clear flags, we should have solid color. Don't clear, I think. Now, if I move stuff, it's should be more or less permanent, I think. It just keeps rendering, and then it'll never regenerate as far as I know, with that clear flag disabled. And then you can also even make it really performant by not having the clear flag, and then you only render it when a particle is emitted, or even if you don't use the particle system. You could use like objects. I usually do that in my game objects. So like a tank in Line War, for example, has this little like a plate under it that's rendering with a specific shader that only outputs it to the render texture. So it knows how to like press down the trees or fold the trees. I do so when it comes into the trees, it'll actually check the direction and then fold the trees so the tank runs over it. And now it's actually racing because I need to still, I think it's just resetting it, but you could use the clear flag and then render it on demand instead through code. So camera.render, and that will just send it off once right to the render texture, and it'll do it super fast in a single frame, and then it'll stay like that until you like render it again. But now it's continuously rendering, so it's not really doing that effect now. Okay, so can enable this one again. And I'd say the performance on this, even if we bump up the render texture here, it's only at 256, 256, 1024 by 1024 we could do it. It's much high resolution on the render texture, but in my experience it's been like super performant. Take this one away maybe. And then should we up this even to like 200 particles? And we can change maybe the start size, randomize that a bit, random between two constants, 0.5 and 2. And this one's rendering 4,000 particles now to a 1024 by 1024 texture. And here, even if it's, we'll go here, shaded wireframe. I mean, it's so many polygons now that it's actually ridiculous. And I've got a good graphics card. So it's at 2080 Ti, so it's not the best, but it's good. And so you probably couldn't get away with maybe like as much, but overall I found it to be super performant. So the likes of rippling after boats or something, or if someone's walking in water, you need to move this locally, so it's not spanning across the whole world. You can move that so it's only like the viewport in range of the camera that's being affected. And so we still have the, and let's see. You could stick this on different objects as well. It doesn't have to be on a flat plane like this. Maybe we'll put some noise on here as well. Noise. Scroll speed. Strength. All right, I'm going to check the chat now. I've been doing this for a long time. How long have I been doing? Over an hour. Over 9,000? No, probably not. Is anyone left? Have I lost everyone? Came here for Blender. All right, let's go. Nifty stuff. Should I read from below and up? Winter racetrack with this effect. Yeah, stick design. That perfect for the low poly racing. 100% I'd go for something like this to get terrain and indentation. So we're taking it again from low poly into something else, but it'd be cool to have it either in mud sections or in like in certain areas at least. Cool with the indentation. Snowfall, perfect. You can actually have a particle systems that like drop snow on. You have the don't clear flag, so it adds up. And then you have cars like removing that from that render texture. Super good. Also water, if you like splash into water, you can imagine you just have a ripple effect. And instead of calculating the normals like I did on this one with a grayscale, I would probably have a ripple ring that's colorized with the correct vectors. So it's like a bump map that already contains the red and green and blue components. So I don't have to do that whole thing with the four nodes to create that weird tree. I just like output that normal map as a single colorized RGB texture and increase it over time like this, and that'll ripple it. So if you want like cars splashing into the water, or like if you're playing like Fortnite or something, when you're running in the water, they're using that technique to just affect the area around it. All right, still here, Eric Pug. Cool. Some people. Let's see. $80 people still here. Did it make any sense at all? The way I tried to explain everything. I hope so. Yeah, waves would be cool. I agree. Could you do destructible terrain with something like this? I just joined. Well, regardless of if you just joined, you can do destructible terrain. The good thing about it is that it's super performant, and I use it again in Line War a little bit. I'm going to increase the usage out of it a little bit more. So when a crater blows up, I do like only a normal map now, but you could definitely have it that it affects the terrain. The only downside is that the graphics or the colliders have no clue what's going on. So that's a problem. If you wanted a crater or to deform the terrain like significantly, so you actually go down into the terrain with like when you walk or something, then you have to do it both ways. You have to, maybe you do that high detailed stuff with the render texture, but you'd have to actually, unfortunately, change the collider mesh as well. Trickier, but it works. Oh yeah, Jonathan asked if it's possible for the collisions. So not out of the box like this. This is only a visual effect, unfortunately. So for collisions, you'd have to do it on the mesh as well. But usually the collider mesh is a lot more primitive than the world terrain. So I'd probably wrap like this very similar logic into a C# script that goes in and affects those vertices, because it's quite easy to do vertex manipulation in Unity as well. You can access all the verts in a mesh as long as you operate in the same location as you do on the texture in this case. But in this world, it's the same texture space. So like it translates correctly, which is quite nice. In our game, it doesn't 100% do that all the time. So then you could actually offset, do a similar calculation, but maybe if the visual representation is like 1,000 verts or something, or 10,000 verts, you can do the visually really fast, but then for the collider, it'd be slower. But it's doable. Yeah, so Amplify package. For the past 2 years, I'd say I've looked continuously at shader labs back and forth. I said that in the beginning of the video as well, and I really, really want to do this in the shader graph editor, in the shader graph. But every time I try, I run into like unsupported feature, or it doesn't do this and it doesn't do that. It can't do the vertex manipulation, and the geometry node doesn't exist in the URP pipeline. So that's why I've decided to, for productivity, I'm going to stick to using Amplify until that's sorted out. And most of the time, I think I'm even going to stick to the 3D pipeline that is so much simpler to use than the URP and the HDRP. So until I'm proven wrong or something, I'm going to be doing that. So, all right, Jen. So yeah, thanks. I'm gonna. So yeah, I can imagine if you're coming from like the Blender world or don't do development and stuff like that, this is probably super strange and weird. But maybe it's an insight to see, like when you see some of the effect in games, you can sort of see the most common one is like the rippling effects. I think that's what this is predominantly used for. And I'm a little bit surprised over how performant it can be. Because when you think about, think about when you're working in Blender, if you're coming from the Blender world, and then like when you do sculpting or something, it takes a bit of time. It's a bit sluggish to do some of the sculpts and stuff. And I find it a little bit strange and cool that it's so performant that you can do it so many triangles that the graphic card has to do. So I'm quite impressed that the performance is out of the box like this. can do. I'm just thinking of the days when I used to program like the first top-down racing game that I used to do, and I couldn't even get semi-transparent meshes like in place. I had to fix like fake the transparency with every other pixel and things, and still I ran into performance problems. And nowadays, like only 20 years later, I guess that's quite a long time, but it's like this is done on the fly. I think it's pretty cool. All right, Fat Cat, I'm just finishing off the stream. Actually, I spent some time to create a render texture and had a particle system render particles onto texture that I used to deform this plane here. Using it. We can disable the tessellation again, so you can see what it would look like without the tessellation. So, and of course, it's not supported by all the graphics card, but I think nowadays most graphics cards are supporting this. Let's see, where did my shader graph editor go? There. So if I disable tessellation now, this is what it looks like without. Slightly less impressive. So this is the original. If you imported a super detailed mesh from Blender, for example, or if you did it procedurally, it'll look better again. So tessellation is just a way for the graphics card to do this on the fly again. So I'm so impressed that it works like that. All right, let's have a look. Ooh, I hope I didn't miss anything before as well, but Arishes, thank you so much for your great contribution here. Super chats are really helping me out. Love your Unity stuff. Thanks for the great tutorials. Thanks. So the idea now is to do a bit of this stuff on the Thursdays. So I'm going to do maybe the live streams, and then I want to put together really compact tutorial, so I don't have to go wonder what I did wrong here. Like when I did had it plugged into the emission, for example, for like 5 minutes without realizing, or when I'd flipped the cross vector. Maybe I should try to explain those a little bit better. And I think it'd be good for the channel as well to get those type of videos there, and then in the live stream I can answer questions and stuff at the same time. So thanks again, Irishes, for that great contribution. Really appreciate it. Jen Abbott, by the way, Imphenzia, you can use C# in Godot, but the native language is GD script, similar to Python. Okay, cool. Great. Well, pardon. I really like C# because I learned it pretty good now. And I've actually learned Python as well. Well, I wouldn't say that I've learned it, but I've programmed quite a bit in it now to script automated stuff for Blender, both outside of Blender and inside of Blender. So a lot of mesh assembly stuff, randomization stuff. And I hated Python before. Now I don't hate it as much, but some of the stuff is really accessible, I think, but it's tricky. Great. Thanks, Eric. Glad you enjoyed it. Let's see. Thanks, Mikita, as well. Glad you liked the tutorials. And Eric, yeah, shaded graph, very irritating. But I'm the only one I work with this. So. But let's see. But I'm the only one I work with that knows it. Okay. I've given it so many chances, and every time, like I said, I go in and it's missing the features that I really need. And I Google it and I think it must be implemented, and no. It's in the request forums, like, we must have tessellation for our URP, or we must have it for, even for I think it just came into HDRP in this version of Unity that was just released. And like in Amplify, I've been using it for how many years? I don't know. All right, cool. So I'm not going to scroll too far up into the history. So, oh yeah, I'm glad Z, that you're saying about the problems, and I can't really emphasize that enough. A lot of people I think when they watch tutorials that the people behind them just know them, and maybe some do. I definitely do not. I spent so much time. Like a normal game dev for me is I'll tackle a problem and I'll start searching, or I'll think of different methods that I know from the past, roughly like how to achieve it. And then I do a lot of time searching. And even when I start to get on the path, I run into problems all the time, especially like with my code, like with the shaders. So much is, for me, is trial and error. And it's quite funny. My coworker, Christian, who's one of the developers, he's the total opposite of me. He reads something like from start to finish over like a day, and then he knows how to use it and he programs accordingly. My brain doesn't work like that at all. I need to test it, and I sort of just knew that if I had, like with this angle, for example, with a normal direction, I knew that like it must be averages between points, so I sort of figured that one out, and I knew that it was vector math, and I remembered something like that. There's the cross product and stuff, so I sort of go along that line, and then I do a lot of test and error, trial and error. So I try it out, and I go, oh, okay, it did get shaded, but it's in the wrong direction. So instead of like learning the math the way I should probably do it, my brain isn't really capable. It's faster for me to just go, okay, if the shadows are inversed, it's probably that I got the X and Y like mixed up in that case, or that it needs to be like inverted instead. So I spend a lot of time doing it like that. And this is not 100% accurate way to do the normal maps either, but I usually go for like the visual result. That's the more important thing to me. If it looks good enough, it doesn't have to be 100% accurate mathematically. So as long as I can get the visual effect that I'm after, that's really what's the important thing for me. And then whether this is the exact correct normal or not, I'm not too fussed about that. So as long as it looks the way I want it to, that's the important thing. Oh, cool. So some of you actually liked me to run into problems. That helps you the most. That's good. Yeah. All right. So Ola Jetgrove Jetlund, thanks for picking up that middle name. It makes it a lot easier now to realize who you are. No, just joking. Tessellation is wonderful to use when you fake color and vegetation movement underwater. Yeah. But this stream makes it so much easier. Thanks. Yeah. I mean, it is, like I said, this one was not with a single line of code. So if you weren't, like, I think we can check the shader code here, actually. Let's have a look. I used to write these, like for my planets and my procedural planet stuff, I had to write all of this stuff. But this is what those graphs generated this code. So the render texture, everything would be in here. This is the stuff that I exposed as properties. We had the different floats, so I used to type these instead. The texture sample. And then it's defining all, like setting up the access to the variables, and then it's going through the vertex stuff and the surface shading. Luckily enough, in Surface Shader, it's built in. I used to have to do all the lighting and unpacking of normals and stuff, but that's built in with the surface shaders. And this stuff down here is just to describe what the nodes are. So this stuff you wouldn't have to type. This is only to do the connections and stuff. One thing I want to show in here that's pretty good is that you can mark a few of these and press C, and that frames them. So you can do like name these things, which is pretty nifty. All right, let's see. Mia PC, what is faster for you, doing it in nodes or typing it, including bug fixes? Oh, do you mean the shader? If you mean the shader, nodes any day. It's for visual scripting, it's much faster to type code. Like if I were to try to do Bolt or maybe a blueprint in Unreal Engine or something, then I'd say that programming is faster for me. But for shaders, any day it would be the node system, because you just first of all, it's just difficult to know the language, the shading language, and it's very unforgiving when you program shaders. You don't really get an error message, and well, you can get them. You get some error messages when they try to compile and say which line it's wrong, but debugging it's really tricky. So the only way you can really debug, like let's say you wanted to know what the value, sometimes you'll get that it overflows or something, or you don't really know. Then the way to debug, the way I often do that in shaders, is that I'll plug like a value here into the albedo, and then I'll check what the colorization looks like, and then I see if it's correct or not. And sometimes if you're doing like ranges, like gradients and things like that, the easiest way to troubleshoot is actually just to plug it into the visual and see, and then try to figure out what's happening. So I often do that one. I'll move that one onto the albedo and I see how it colors it. Sometimes with specific colors and stuff too. I haven't tried the Houdini yet. I want to try Houdini for the procedural generation. That would be fun. And I haven't used Unreal Engine. The only thing I've used Unreal for is that I actually published a few of my assets in there, some of the sound effects and space boxes. But I really, really want to try, especially Unreal Engine 5. I was a bit disappointed to see the comments when I did that tweet about the bloat in Unity, that apparently it's very, very bloated, I believe, in Unreal Engine 2. Like a new project is huge. But I don't know if it's as bad. As a reference, when I did my procedural planets, I had to break a lot of new ground to do. But I think I spent a year programming my procedural shaders for, I'll show you like this stuff as a few examples here. I'm just going to bring up something here. So here. These shade comes with music apparently. I'll turn it down. So these planets those are the shaders that I coded, and then I used procedural materials. I used Algorithmic's procedural materials that used to be integrated in Unity. They were built in. Super nifty way to just generate procedural like splat textures and all these cool valleys and everything like that. I managed to build these procedural generated node stuff. Worked great, and then programmed the shader to get the atmosphere, to get like how it blends. It's quite difficult to blend stuff around a sphere because you get seams at the top and the bottom. Like try to wrap a square texture around a sphere. It looks great from the equator, but when you get up to the top, you usually get significant pinching. So that's all solved through like crossfading within the shader and stuff. And I think I spent about a year on and off in my spare time. And I don't know how many hours I spent like programming this shader. And then when it finally came to doing, I did like the gas giants after. I don't have that in this video. Then I decided that I had learned the Amplify shader editor, and I replicated the work in one day that I had spent over a year doing. But it's not really fair to compare it that way because I had to learn so much about how to assemble the planets. But if I were, like maybe I can compare it if I needed to recode the shader manually instead of using the nodes. Even if I'd learned how to do it, and even if I know roughly what commands to use, I'd say like in order of maybe 20 times longer to do it if I didn't use it, like if I had to program it instead, maybe 10 to 20 days instead of 1 day to do it with the shader editor. All right. Oh yeah, Matt, I agree. I think in geometry nodes and just the general thing to use a texture to offset vertices. And I used grayscale now, but you can definitely do it with RGB textures to send them off in any direction. You can really get some cool effects to get like warping and things like that. So if the planets are a shader or a full 3D model with depth and everything, so yeah, it's just a shader. It's a sphere. And the shader does everything. That's why you cannot land on them. You can't transition into terrain. I had so many questions to say, "Ooh, this is great. Can I land on them?" And my answer is always no, because I wanted to create planets that look good from space. That's my main interest. I knew, like with the likes of No Man's Sky and things, it was popular to start making games where you transitioned in and out of them. But I always ended up having a loss of quality of the space view of the planets if I were to try to make them seamless to land on. So, and this asset that creates all these planets, it's only, it was at least only 5 megabytes in size. So I was quite happy with the fact that it could produce, because the equivalent texture quality, it's doing a lot of crossfading and tricks within the shader as well. But if you were to try to achieve this result with a single texture map, it would be about 60,000 by 60,000 pixels in resolution. And then you'd need the bump map for that one as well. And you'd need, so the shader is doing all of those. Maybe I'll cover that in a video, because you can do a lot with something called lookup textures. So even if you've got like a low resolution terrain texture, then the graphics card will interpolate and fade between the values to cover the distance. And then you can use a lookup texture, and you can gain like an incredible amount of detail, and it looks like it's the most detailed texture map in the world, but it's actually just finding a sharp line within like low resolution, the faded texture. So a lot of this one, like this texture, for example, is 512 by 512, I think. And again, if you tried to replicate it with a texture that wrapped around the whole planet, then it'd be 60,000 pixels or something. All right, cool. Okay, I think that's going to be it there. So an hour and a half, this stream was fun to hang out again. So I hope you enjoyed the little view into Unity stuff. So hope it gave some. Always, you can go back and look at the shader code. You could replicate it in shader graph if you spent enough time to do it, and you just have to figure out how to do the tessellation somehow. But the general like type of nodes, like of dragging the stuff into like vertex offset, sort of works. But it's I just don't like it as much. So. All right. Okay, folks. So come back next Thursday for another video, and maybe I'll drop a tutorial soon in between everything. So that would be nice to get actually a regular video. It's been nearly a month since I released a regular video now, so let's mix it up a lot. And I hope you have a great weekend coming up to Christmas as well. So make sure you've got everything prepped and planned. And I'm going to see you next week. So take care, and bye for now. I should have used this camera.